Alright, this is the last video for section 1.5, and it's on writing answers to inequalities. There are three parts when you're doing an inequality, three things that I want you to do. And the first one, which we looked at in the last video, is to solve it. Second one is to graph it. And then the last one is to write the answer. And when you write your answer, there's two different types or formats you can use. First one is called set builder, and it's probably the more common of the two, set builder notation. But you will also see interval notation. Both of them can be used. It's up to you to read the directions in your homework and when you're taking the test as to which one you're supposed to use, but both of them can be used. So if you're taking an ACT test, for example, you may see both of them. They may both show up because they're both acceptable. Now, I'm assuming that you understand the first two steps already, how to solve an inequality and how to graph it. So we're starting out with two simplified solved answers. We've got x is greater than 3, and then x is less than or equal to negative 2. We're going to look at these two when we write our answers. We need to have them graphed, so we're going to go ahead and graph these. Remember, when we graph them, we need three numbers. 0, the number in our inequality, and then the number that's the opposite of the one in our answer. So for our first one here, we have negative 3, 0, and positive 3. We want to use an open circle because it's not equal to on positive 3, and then we want all the x's that are bigger than that, so we shade to the right. For our second one, three numbers, 0, negative 2, and positive 2. It's equal to, so we're going to use a closed circle on negative 2. And this one we want all the x's that are less than negative 2, because remember that makes that L shape. So we're going to shade to the left, because that's where all the numbers smaller than negative 2 are. So there's our two inequalities when they're graphed. First type of notation we're going to look at is set builder. Alright, set builder notation. It uses curly brackets. So you're going to need to get in the habit of writing curly brackets. What we do is we start with a curly bracket, we put the variable, and then we draw a line. And then after that line goes the simplified inequality with the variable on the left. And it's important that the variable's on the left. And then we close our brackets. So that's one of the reasons I told you when you're writing your answers, your variable always needs to go on the left-hand side. And it's that easy. So for our first example here, we've got x is greater than 3. To write that in set builder notation, be x, because that's our variable, line, x is greater than 3. And we're finished. That's all we have to do. For our second example, x is less than or equal to negative 2. Curly bracket, variable, x, draw a line, x is less than negative 2, close our brackets. That's it. Now you might be wondering what that stands for, what that means. When we set up set builder notation like that, it stands for, the way we would read it, is the set of all, and this is where our variable is, x's. The set is what the curly brackets mean. X's is our variable. The line means such that, and then we say our inequality. So we're looking for the set of all x's such that x is less than or equal to negative 2, that our x's meet that requirement. And that's how we would read set builder notation. That's what it means. So that's the first type. It is the easier of the two, set builder notation. Second one is interval notation. And it's important for interval notation, one thing I like to tell people is to graph it first. Because if you graph it first, it'll be easy to tell how you're supposed to write your set builder notation from your graph. Or, sorry, your interval notation from your graph. Now, interval notation is a little different. It uses some different symbols. We're going to use parentheses, brackets, and then infinity signs, either positive infinity or negative infinity. Open brackets, or parentheses, are used when we have open circles and on an infinity sign, and that'll make sense here in a minute. But open circles, not included numbers, get the parentheses. The square brackets are for closed circles, filled in circles. And then infinity signs are whether we're getting larger or smaller, depending on which way we shade. Negative infinity is shaded to the left. Positive infinity is shaded to the right. So we're going to go back, and I'm going to real quickly sketch our graph again so that we have it to look at. 0, 3, and negative 3. Open circle shaded to the right. Now we read it from left to right. That's important. So we start on the left-hand side, we're going along, and then we hit 3. And it's an open circle, so we would have our parentheses, because it's open, write our 3, and then a comma, and everything to the right then is shaded. And if everything to the right is shaded, we use infinity. And infinity signs always get open parentheses, okay? So that's the first example in interval notation. The second example, we had our graph, 0, 2, and negative 2. Negative 2 was closed, and we shaded everything to the left. Again, we go from left to right, and if we start on the left, everything's already shaded. So we've already got numbers that are included in our set. That means we're going to start with negative infinity, because the left-hand side of the graph is already shaded. So we use a parenthesis, because infinity always gets parentheses, negative infinity, a comma, and we go until we hit negative 2. At negative 2, it's included. It's a closed circle, so we use a square bracket. And there would be interval notation for our second example. And that's how we write our answers, either in set builder or interval notation. Now we're going to do an example. And in the example, we're going to put all the stuff together. We're going to solve it, we're going to graph it, and then we're going to write our answers in both set builder and interval notation. So here's our example. We've got 4x minus 3 is less than or equal to x over 2. So to solve it, we're going to multiply both sides by 2. And we do that in order to get rid of our fraction. Now on the left-hand side, we need to distribute. We can't just multiply it by the first number. It has to get multiplied to everything on the left-hand side. So 2 times 4x is 8x, and 2 times negative 3 is negative 6. Is less than or equal to. We don't need to switch the sign because we multiplied by a positive, not a negative. So the sign stays the same. And all that's left on the right-hand side is an x. Now you could do one of two things. I'm going to go ahead and bring the x's to the left because that's where they're going to need to be because I want my variable on the left-hand side. So I'm going to go ahead and add 6. And again, the reason I'm doing that is to get my x's on the left. So we have 8x, 6 is canceled, it's less than or equal to x plus 6. And now I'm going to subtract my x. So I have 7x is less than or equal to positive 6. One more step, we're going to divide by 7. So the answer is x is less than or equal to 6/7. Notice I didn't have to switch my sign at all in that problem. That's because I solved it by getting my x's to the left. Okay? Now if you solved it differently, you may have to flip it around, you may have to change your sign, you may have to do several different things, and that's okay. Just remember you want your variable on the left. Next thing we're going to do is we're going to graph it. We need 3 numbers, 0, 6/7, and then negative 6/7, the opposite of our number. We have a closed circle on this one because it's equal to, and that's on 6/7. And then we want all the x's that are less than 6/7. So we're going to shade it through the left because that's where all of our numbers that are smaller are. So there's our graph. Next thing we need to do is write our notation. So first thing we're going to do is start with set builder because it's the easier one. Curly bracket. Variable in this case is an x. Draw a line. Then our simplified inequality with the variable on the left. X is less than or equal to 6/7. There's set builder notation. Interval notation. I'm going to use the graph for this one. We read it from left to right. If you look at our graph, we've already got numbers that are shaded. So that means we start with a negative infinity. So parentheses, negative infinity, a comma, and we go to the right until we hit 6/7. 6/7 is a closed circle, so we need a square bracket. And there's our interval notation. Okay, so there's an example that's putting everything together, and that's what you're going to be expected to do. Now, I've got a practice problem for you, and I want you to pause the video, work it out, come back, and then check your answer. So go ahead and pause it and work it out. All right, we've got negative 2x is greater than x plus 5 over 3. First thing we want to do is get rid of the fraction. So we're going to multiply both sides by 3. Now we multiplied by a positive number. There's no reason for the sign to change. 3 times negative 2x is negative 6x. Still greater than x plus 5. Again, I'm going to get my x's to the left because that's where I want them to be at the end of the problem is to the left. So I'm going to subtract my x. Cancel these out. Negative 6x minus x is negative 7x greater than 5. Got one more step. I need to get the x by itself, so I'm going to divide by negative 7. Now here's where some people get caught up, dividing by a negative. So remember, you have to change the sign. So it's going to change from x would have been greater than, now it's going to be less than, negative 5/7. And there's the answer to our problem. X is less than negative 5/7. Next thing we have to do is graph it. Sketch out our graph. Get our 3 numbers on there. 0, positive 5/7, and a negative 5/7. Notice it's not an equal to on this problem, so it's going to be open on negative 5/7. And our inequality calls for all the x's that are less than negative 5/7. That means we're going to shade to the left because that's where all the smaller numbers would be. So here's our graph. We've got an open circle on negative 5/7, and then we've shaded it to the left. We need to write our notations now. The first one is set builder. Okay, we've already pretty much set that one up because we've simplified our inequality. So we do a curly bracket, an x, draw a line, simplified inequality with the variable on the left. X is less than negative 5/7. There's our set builder notation. Interval notation. Again, it's based off of our graph. So we're going to look at our graph. We're going to read it from left to right. And as we were reading it, it's already got things shaded. The left side's already shaded, which again means we're going to start with a negative infinity. So open or parenthesis, negative infinity, comma, we're going to go until we hit negative 5/7. That's an open circle. So for negative 5/7, we're going to use a parenthesis. And then there's our interval notation. So if you got all that right, good job. If you didn't, I'd go back and watch that explanation again, identify where your mistake is at. You need to bring any questions you have to class, and then you are finished. Those are all your videos for section 1.5.